esteemed members, and respected juries. We are honored to have you join us today for the presentation that introduces groundbreaking innovation, the low-cost myoelectric prosthetic arm, brought to you by a dedicated team of Herculean. Our journey begins with the problem statement, low-cost myoelectric prosthetic arm. We are Team Herculean, and I am Om Madeshwar, team leader of this team. Our institute, Pillai College of Engineering in Panvel, proudly support us in this endeavor. Our project falls under the theme of MD Tech and it's supported by the Ministry of Social Justice and Empowerment. The challenge is to create a low cost myoelectric prosthetic arm that not only replaces the lost limb functionality but also enhances it. Introducing our innovative solutions, an advanced prosthetic that mimics the natural arm functions. It's ergonomic, customizable, and built with durable lightweight electroactive polymer material. Here are some key features. Powered by EMG and IMU sensors with BLE connectivity, controlled by Arduino Uno, EAP technology enables the natural arm-like movements, provide haptic feedback for sensory perceptions, long-lasting battery for uninterrupted usages, benefits amputees, healthcare, and also for the industrial purposes.
Coming on to sensors, so far we have used EMG sensor for input and servo motor for output interfaced with Arduino Uno. EMG sensor consists of three electrodes, two of them are placed on fat muscle area and one reference electrode is placed on bony area. The signal connected on contraction or relaxation of muscle is amplified and sent to Arduino. Arduino Uno is a microcontroller used to process signals and take decisions. Servo motor consists of three pins, signal, positive and ground. Signal pin is connected to PWM pin of Arduino Uno, here digital line, and works according to received signal. This is overall circuit diagram. EMG sensor requires external voltage. It sends amplified input to Arduino who processes it, plots the graph as mentioned in code. These are the graph that we have obtained for different hand movements. The threshold values are specified in code according to this graph and function servo motor accordingly.
I would like to show you the circuit diagram used to control the prosthetic arm. The EMG sensor sends the signals to the microcontroller, which gets the signals processed and filtered to the software to actuate the movement of servo motor and EAP material. One servo motor is used to control the wrist movement, the other servo motor is used to control the hand movement. Five force sensors and five temperature sensors are used to prevent the damage to the prosthetic arm due to excess loads or temperatures.
The bionic arm structure begins from the elbow, making up for an upper limb amputee who is amputated from below the elbow portion. The bionic arm will be a 3D printed model in which honeycomb structure is in sandwich pattern, which is lighter in construction and will provide a higher strength to weight ratio for the arm. Placing the ionic EAP, that is, wet electroactive polymers, inside the 3D printed model fingers, these EAP actuate when there is movement in ions of the polymer. They require drive voltage of 2 volt. The EAP sheets are also designed to be a honeycomb structure. The EAP is a substitute for the strings which are used for actuating the fingers in the previous version of the bionic arm. Signals from the electromyography sensor goes to the Arduino which regulates the battery to send the signal voltage to these EAP for actuating the fingers. From this, we get the actuation of our finger for the bionic arm.
The use cases of myoelectric prosthetic arm are: the first is amputee rehabilitation, in which amputee can have second life with the help of myoelectric prosthetic arm. The second is provide enhanced mobility. The person will be more quick and do more activities than before. The third is occupational task. The person with the prosthetic arm can lift 1 kg of weight.
In hardware, we have motor, sensor, battery. In motor, we have servo motor to actuate wrist movement. In sensor, we are using electromyography sensor and Bluetooth low energy chip and battery to provide polarity to EAP material. EAP material is electroactive polymer. It is our showstopper. As the specialty of this material is like it get contract when we provide it with a polarity and it get back to its original shape when polarity is removed. The software we are use like LiveView and Arduino IDE for coding and circuit connection. The communication is through Bluetooth low energy chip between Arduino and electromyography sensor. The material used for prosthetic arm is of light reactive thermoset material and for fingers we are using electroactive polymer. Thank you.